Okay, so in this video we're going to talk about several different ways that you can represent relations that are a little bit more visual in nature. And the first way that we can represent a relation, I've got an example relation listed out on the screen, and we've defined that relation on this set X. Although we're not really told how it's defined, I'm just listing the elements of the relation R for you. But the first representation is what is called a digraph, or sometimes a directed digraph, as we're going to see. So what we do is we usually make a dot or a vertex for every element in your set X, and then we just use what are called directed edges to represent each of the relationships. So A is related to A, and so we just use this is a directed edge. It means it's got a direction with an arrow, and since A is I guess I should label this as A, B, C, and D. And so since A is related to itself, we just draw the directed edge going to that same vertex, and that is sometimes called a loop. And since we have A related to A, B to B, C to C, and D to D, we're going to have a loop at every vertex. And so in a case where you have a digraph that has a loop at every vertex, that would be a quick visual for whether or not your relation is reflexive. Right, we've also got these two, B related to C and C related to B, so we want a directed edge going this direction that represents B related to C, and then also another edge going this direction that represents C related to B. And so that would be a quick check for whether or not your relation is symmetric, right? If we have an arrow going from B to C, then in order for this to be symmetric, there also must be an arrow going from C to B, right? So if we don't have this in the relation, but say we had C related to D, if we use a different color because this one isn't actually in the relation, right? But if we had an arrow here, then in order for this to be symmetric, we would also need another arrow going in this direction. So now, of course, those red arrows weren't actually in the relation that I listed. So we can see that this, if you ignore the red arrows, the red edges, we can see this relation would be symmetric, right? Because since I had an edge going from B to C, then I also had an edge going from C to B. And then you can use your digraph to tell whether or not a relation is transitive, but that's a little bit more difficult and probably not as useful. But what is useful is just that this is a nice visual representation of your relation. And so a second way that you can represent a relation is with what is called a matrix. And so the way that you set up your matrix is you're going to list all the elements in your set X going vertically and horizontally. And then we're just going to form a matrix. So we're going to have 4 rows, one for each element in our set X, and 4 columns, also one for each element in the set X. And we're just going to come to this first slot, which represents A and A. So we'll put a mark if it's the case that A is related to A, which it is. right? Then in this second slot, so I'm just drawing these squares to represent open slots where we're going to place either a 0 or a 1. So the mark that represents that there is a relationship is 1. And if there is not a relationship, so in this open box, is A related to B? No, B is related to B, B is related to C, but A is not related to B. So there would be a 0 there. A was not related to C. A was also not related to D. Right, so anywhere there's a relationship, I place a 1. So B related to B, C related to C, D related to D. So I'm going to have a 1 here, B related to B, C related to C, so a 1 here, and D related to D, a 1 here. And then the only other two places I would have relationships are B is related to C, so that would be here, and then C is related to B, so here, and then everywhere else there needs to be zeros because there are no other relationships. And this is called the matrix of your relation. And so that's another way to visualize a relation. And so you can do a quick check using the matrix for whether or not your relation is reflexive. You want to check this right here, which is called the main diagonal. If there's a 1 in every slot along the main diagonal, then your relation must be reflexive, right? Because you've got A related to A, B related to B, C related to C, so on and so forth. And then another quick check for whether or not your relation is symmetric is just to check, is your matrix symmetric? And when we say that, we mean symmetric around this main diagonal. Symmetric around this main diagonal. So what that means, in order for this matrix to be symmetric, right, when we go across this main diagonal, these numbers must be the same in order for our matrix to be symmetric. And these must be the same, right? And these must be the same, right, across the diagonal. And so it's a real quick check. This matrix is in fact symmetric. This matrix is symmetric around that main diagonal, which means that our relation is symmetric, right? And so you could use a similar idea to check whether or not your relation is anti-symmetric. You would expect that your matrix would not be symmetric around the main diagonal. So, you know, if you had something like maybe a 0 here and a 1 here instead, your matrix would not be symmetric around the main diagonal, and you would expect that your relation is anti-symmetric. Now, we do have to be a little bit careful, because remember that we can't automatically say that when a relation is not symmetric that it is anti-symmetric, so we may have to think about that a little bit more. In fact, I'm going to do an additional example here in just a minute to illustrate that again. However, when our relation is not symmetric, typically we expect that that's a good indicator that the relation is anti-symmetric. Right, and then again, we can do some additional work to use a matrix to determine if our relation is transitive, but that's a little bit beyond what we want to discuss, and it gets a little bit tedious at times, so we're not going to worry about that too much. As I said, I do want to do one additional example where we do have to be careful about whether our relation is symmetric or anti-symmetric, but I will do that one in the next video.